This video is about solving exponential equations with the quadratic pattern. For the quadratic pattern, we know ax squared plus bx plus c equals 0. This x could be a times e to the x power squared plus b times e to the x power plus c equals 0. It could be a times 2 to the 3x power squared plus b times 2 to the 3x plus c equals 0. So how to decide the equation is a quadratic pattern? First of all, it must be 3 terms and easily create a times something squared plus b times something, then plus c equal 0, 4. For number 2, look at this is a negative exponent. We have to change all negative exponent into positive. So we have 4e to the 5x power minus 1 over e to the x power equals negative 3e to the 2x power. We will try to get rid of this denominator by multiplying e to the x power for every single term. So I get 4e to the 6x power minus 1 equals negative 3e to the 3x power. And this time we know this is a quadratic pattern because e to the 6x power, we can write down e to the 3x power then square. Therefore, first step, get equal to 0, 4. 4e to the 6x power plus 3e to the 3x power minus 1 equals 0. 4e to the 3x power then square plus 3e to the 3x power minus 1 equals 0. Then we will make e to the 3x power equal a. Substitution, 4a squared plus 3a minus 1 equals 0. 4a squared plus 3a minus 1 equals 0. Nature x, negative 4, positive 3 over 4 over 4. 4, negative 1, reduce, 1 over 1. Variable is a, bottom up. A plus 1 times 4a minus 1 equals 0. A1 equals negative 1. A2 equals 1 over 4. Then we plug back in e to the 3x power equals negative 1. We know b to the x power always greater than 0. For b greater than 0 and b not equal to 1. Therefore, e to the 3x equals negative 1, no solution. Then we plug into a2 equals 1 over 4. We get e to the 3x power equals 1 over 4. Then natural log both sides. Cancel 3x equals natural log 1 over 4. Then we divide it by 3 both sides. X equals 1 over 3. Natural log 1 over 4. Let's go to number 4. Since we can create 3 to the x power square and also 3 to the x power, it will be quadratic pattern. So we need to create a times 3 to the x power square plus b times 3 to the x power, then plus c equals 0 4. We will use b to the m plus nth power equals b to the mth power times b to the nth power to separate this and also this. 3 to the 2x power times 3 squared equals 5 times 3 to the x power times 3 to the first power minus 6. We will get, this is a 9. 9 times 3 to the x power square equals 5 times 3 is 15 times 3 to the x power minus 6. Since this is a quadratic pattern equation, we need to make it equal to 0 form. 9 times 3 to the x power square minus 15 times 3 to the x power plus 6 equals 0. We have a common factor that is 3, so we divide it by 3 both sides. 3 times 3 to the x power square minus 15 divided by 3, that is 5 times 3 to the x power. 6 divided by 3 will be plus 2 equals 0. Then we will make 3 to the x power equals 8. We will get 3a squared minus 5a plus 2 equals 0. Negative x, 6, negative 5 over 3 over 3, negative 2, negative 3. So we have negative 1 over 1. Then bottom up, 3a minus 2 times a minus 1 equals 0. a1 equals 2 over 3. a2 equals 1. Then we plug back in. We will get 3 to the x power equals 2 over 3. 3 to the x power equals 1. We know this is x equals 0. So for this one, we will take log base 3 both sides. We will get x equals log base 3 of 2 over 3. If you want to, you can expand the log equals log base 3 of 2 minus log base 3 of 3. That is log base 3 of 2 minus 1. You can leave your answer as this, or you can expanding the log, get the answer like this. If no special solution form is required, both will be correct. Let's go to number 5. X to the natural log of x power equals e. First of all, we will take a natural log of both sides. This natural log of x as an exponent, we will drop down. Get the natural log of x times the natural log of x equals natural log of e equals 1. So we get natural log of x squared equals 1. Square root both sides. We will get natural log of x equals plus or minus 1. So we separate natural log of x equals 1 or natural log of x equals negative 1. We know a equals c. We can write down b to the a's power equals b to the c's power. Therefore, I can make e as a base for these two equations. Also, we know a to the log base a of x equals x. So this one, we will get x equals e, or x equals 1 over e. We have two solutions for question 5.